So this will be the second video for Notes 19, and we're dealing with still more factoring, but this time we're talking about factoring the difference between two squares. And the basic idea between factoring two squares is that you have two quantities that can be written as something squared and something squared. And the mathematical word for difference means that we are subtracting. So it is the difference, the subtraction of two perfect squares. And when you have that situation, you're going to take basically whatever your a value is, not the a squared value, but split the a and a, split b and b, and then make one of them positive, one of them negative. Which one's positive? Doesn't matter. Which one's negative? Also does not matter. You just have to have one of each. So if we take a look at question number 1 here, if I want to do the rewrite to show you the difference of perfect squares part, well, x squared is already something squared. If I try to write 36 as something squared, that would be 6 squared is 36. So to break this up into two factors, we're going to split the x squared. We're going to split the 6 squared, make one positive, make one negative. And folks, you've just factored the difference of perfect squares. Now, if you don't believe me, you're looking at this going, there's no way, that's not it. Well, what you can do, I'm going to take the box off, is you can check your work. I do this all the time, but this time I'm actually going to show you what the check looks like. So if I take x times x, that's my x squared. X times negative 6, negative 6x. The x is now this x is now fully distributed. Now I want to distribute that 6. So positive 6 times x, so plus 6x, and then positive 6 times negative 6 is negative 36. Now you might be looking at this going, but wait a minute, that doesn't match the original, and that's what's supposed to happen. Except these two middle terms, you have a positive 6x and you have a negative 6x. When you combine those, they eliminate each other, leaving behind simply x squared minus 36, which is in fact what you started with. Now, after showing that check, I do want to remind you the answer is still the factors that you had here, the x plus 6 and the x minus 6. This again was just my work to show my check, right? Literally show it to you so you understand why it works the way it works. All right, so that's part A. If we move on over to part B, I can do the same thing. We've already got b squared minus 9 is nothing more than 3 squared. So if I go to write my two factors and split it, there's b and b, 3 and 3, make one negative, make one positive. Order doesn't matter. I don't care. It won't matter. So to do the quick check, b times b, b squared. Negative 3 times 3 is negative 9. If I multiply the middle two, I get a negative 3b. Multiply the outer two, positive 3b. Those cancel. All right, so yes, I know that part B is accurately factored. Part C, this one's a little bit weird because you've not seen that 4 before, right? Or some number in front of the x squared. Or if we have, oftentimes we've been able to factor it out. And unfortunately, no, we are not going to be able to factor out a 4 here. But what you can do is, just like we rewrote 9 as 3 squared, we rewrote the 36 over here as 6 squared, I can do that with both 4 and 25. So 4 is 2 squared, right? X squared stays x squared, minus 25 is 5 squared. So if I go to write my factors here, I'm going to pull a 2 and I'm going to pull an x, so 2x and 2x, and then I'm going to split the 5 squared, so 5 and 5, make one positive, make one negative. Notice that these two pieces, the 2x here and 5 and the 2x here and 5, they match. The only difference is one's positive, one's negative. That's what's going to cause that middle term and when you multiply them together, and the outside term when you multiply them together, to cancel. So 2x times 2x, 4x squared. Positive 5 times negative 5 is negative 25. Positive 10, negative 10 when you multiply them together, they cancel. So there is the factored form for part C. Moving on over to part D, this one looks a little bit goofy because here's the thing. You have a GCF here. So let's go ahead and factor that GCF out first. These two terms both have a single x in them. I'm going to take it right on out. And that leaves me with p squared minus 4, which that follows the pattern that we've seen with the difference of perfect squares. Now for this one, I am not going to write the two pieces, meaning I'm not going to rewrite this as something squared. I'm just going to go ahead and fill that in for my factored form. So what squared is 4? Well, that would be 2 squared, 2 times 2. Make one positive, make one negative. Quick double check. P times P is P squared. Negative 2 times positive 2 is negative 4. Positive 2P, negative 2P, they will cancel. All right, part D is all done. I'm going to go ahead and slide on down to the bottom row here. I'm not going to say that these get any more complicated because they really don't, but here's the thing I need you to pay attention to with part E. While I can rewrite this as, look, it's z squared, this is 3 squared, there's the plus sign, but here's the problem. The whole thing, this whole factoring set is called the difference of perfect squares, meaning you have subtraction. That is not subtraction. The z squared is not negative, the 3 is, there is not, you can't factor this, right? I don't care what you do to this problem, part E is not factorable. Okay, don't get hung up, don't get weirded out because, but look, it can be rewritten, it doesn't matter. It's the difference of perfect squares for a reason. There is no difference here, meaning no subtraction or no negative sign. You do not have a factorable example here for part E. All right, now part F looks a little goofy because the negative is coming first. So, well, okay, I'm just gonna rewrite it. So I can do that, m squared minus 49. The m squared was positive here, m squared's positive here. 49 is negative here, 49 is being subtracted, which means it's a negative there. That is perfectly acceptable. So go ahead and write your two factors, split the m squared. We're also going to split the 49. The only way to split 49 using the same number is 7 times 7. Make one positive, make one negative. All right, I know that will work. That is the factored form for part F. All right, sliding over to G, you have a weirdness here because the number is first, but oh well, the number can come first. I just like having the subtraction sign in the middle because that way I know exactly where to put my signs. So I'm going to write my two factors. Because 81 comes first, I'm going to split that first. 9 times 9 makes 81. Then I'm going to split the n squared. N and n, make one positive, make one negative. This one I am going to show the check really quickly, right? Okay, 9 times 9 is 81. Negative n times positive n is negative n squared. Minus 9n, positive 9n, that creates the 0 term or no term in the middle because they cancel. So G is all good to go. All right, part H here, we basically just have variables. The exponents are numbers, but bases are just variables. And this one's a little bit weird here. That's k to the 4th. Well, k to the 4th is actually k squared squared. Okay, so this still follows the difference of perfect squares. When I go to split this, to split up the k to the 4th, I am going to have a k squared times a k squared. To split up m squared, I would have m times m. Make one positive, make one negative. Double checking my work. K squared times k squared is my k to the 4th. M times negative m is negative m squared. This would be a k squared m. This would be a negative k squared m. So again, those terms will cancel out. So there's my factors for H. And I kind of think I is the last problem. I'm going to finish this one. I double check to make sure we got them all. So first thing, I look at this one. Immediately, I see that I have a GCF. So I'm going to factor out 1p from each term. And this difference of perfect squares, I think I've done it 3 times already. So we're going to split the p, right? There's p and p. Split the 4, 2 and 2. Make one positive, make one negative. P times p, p squared. Positive 2 times negative 2 is negative 4. 2p, negative 2p, they will cancel. There's all my factors. I think that's it, but let me pinch in. All right, yep, that's going to be it. So that's going to be the end of the second video for Notes 19. As always, let me know if you have any questions or concerns, and I'll see you in the next one.